Hello, everyone. Thank you for joining us today on this session that is part of the MIA series, where we are hosting where we are hosting Azure leaders and MVPs from across the region to learn from them all about the latest in technology. And in today's session, we're coming here together to learn all about Terraform and on Azure and all the fundamentals. Excuse me, I'm not sure what's happening. That is used as an infrastructure, as a code, and it will help you make your life easy in an enterprise environment. I'm sure you know me by now. I'm Hassan Mahsine. I'm the program manager for Microsoft Reactor in Abu Dhabi, and the reactor here in Abu Dhabi is physically located in Abu Dhabi, but it's also open to all the members and communities across the Middle East and Africa. And we're working very closely with everyone to make sure that we're reaching and upskilling and enabling everyone who is passionate about technology across the region access our sessions and enjoy and benefit, and we're listening to the feedback that we're getting from everyone. So excited to have you all with us. The session is recorded as usual, and it is available on our YouTube channel. It will be available in the next 24 to 48 hours, I would say. So enjoy today's session. Ask as many questions as you wish to our expert speaker. And don't worry, you will have it on demand on the YouTube channel, so you will have a chance to review it later. As always, it's a great pleasure to host Sathesh, who is an award-winning information technology professional with a decade of experience. He's an Office Server and Services MVP award winner for the years 2014 till 2021 for his exceptional technical contributions. He specialized in cloud, Microsoft Cloud, Office 365, Microsoft Exchange, and he has been doing a number of projects worldwide in designing, supporting, and implementing messaging and virtualization infrastructures for medium-sized businesses to large enterprises. And further to that, he's a cloud architect and a technical advisor for various startups. And you can visit his technical blog, azure365pro.com. I'm going to link that in the chat for you to visit. As always, do not forget to check in. The check-in page can be found on this short link, and then you will use the event ID for today's session. And that is your way to access the event resources and the survey. This will help you, first of all, continue the journey after today's session. There are some modules recommended by Sathesh that will help you continue the journey and not stop just after today's session, 1 hour session. And then that's it. If you want to continue and do more learning around the topic, then you will need to follow the modules recommended on there. And also there is the survey. The Reactor survey link is there, where you can send us feedback about today's session and also about the sessions that you would love to see at the reactors in the future. This will help us program and bring to you sessions and topics that you would love more. So please take a moment after today's session to do that survey. And before we begin, this is a standard one, and you've been seeing this a lot, I'm sure. But in short, this is a reminder that we're all coming here to learn, coming from different backgrounds. So let's be aware of others, friendly and patient at all time, and welcoming and respectful, open to all viewpoints and questions, understanding of each other's differences, and kind and considerate to others at all time. That's pretty much all that I have for the introduction. Thank you, Sathesh, for joining us today on today's session and taking part in this MIA series. We are always happy to have you in the reactor from the early days where we were doing in person, and you were like one of the first MVPs, I would say, that collaborated with us. So always a great pleasure to be working with you. And yeah, I think, yeah, I can see your screen right now. All right, that's all for me for the
Sure.
introduction.
Thank you so much for
Sathesh, for
your
joining
great
us.
introduction, Osam. I'm truly grateful for all the opportunities speaking via Reactor. Let's do a great session together. Whoever is joining and spending your valuable time with us, we are truly grateful for this. Because spending your time with us to learn for yourself, and it's a good thing for us. And definitely, we will do something great together, and we will learn something nice today. Yeah. So. So yeah, so let's talk about Terraform on Azure today. So I don't want to spend much on slides usually, but this topic I don't think I can do it without slides. So, and also I would like to have this as an interactive session. So if you have any doubts, please put it on chat. We can have the doubts cleared then and there, so that we can have a smooth session. And when you go out of this session, I really want to want you guys to learn something new, because it doesn't mean like I know everything, but whatever I am learning throughout my career, I am just trying to share the knowledge then and there, so that we learn together and grow together. This is the approach we are taking. So we run a lot of groups. I run blogs. I'm MVP for many years. So I share my knowledge always, and if you guys have any other thoughts, please put it on the chat. If you have doubts, put it on the chat, or if you have any clarifications, let's talk it out so that we can have a great discussion, and let's start the session. Okay. So today the session will be on Terraform and Azure, Terraform and Azure fundamental session. We will not go into like too much advanced topics. We will go into a overall Terraform session. So let's consider what is Terraform. So the first point is, what is Terraform? And Terraform is the infrastructure as a code. Infrastructure as a code is kind of a buzzword we guys are using. In any company you enter now, have you guys implemented infrastructure as a code? Have you guys implemented DevOps? Have you guys applying AI? So this is kind of buzzwords, and it's also good for the environment, but so it's very predominantly used nowadays in the US Middle East market. Middle East market is kind of booming with Terraform. More companies are starting to adopt Terraform. US, UK, and more companies have already adopted there. So it's why I'm saying this is it's more important to know these type of topics nowadays. So that's why I chose this topic. And we have implemented in quite a few projects, and it's completely stable. Things are great with Terraform. So Terraform is infrastructure as a code, and infrastructure as a code. Why we need infrastructure as a code? So because anytime we can just use any sort of PowerShell or AZ login or ARM templates, and we can use Terraform, right? So we will go into that. Why we really need Terraform? We will discuss those things as well. So what is Terraform? Terraform is infrastructure as a code. Like infrastructure is in the code, in the sense like you can specify like 5 to 6 lines, or whatever you want to create, you can specify as a code, and you can push it through any Git system, and you can populate the infrastructure like a software product. So that is called Terraform. And why and ARM templates and biceps from Microsoft. Why Microsoft is also recommending Terraform in few instances, like why ARM templates and biceps. Bicep is a new product released by Microsoft, and ARM templates has been there for a while, the JSON form templates. So all these Microsoft products are there, but still Terraform is booming in the side, because ARM templates is like too complicated, and if there is any error on these JSON files, if you miss any kind of a double quotes, or if you miss some formatting issue, it's extremely hard to troubleshoot. So ARM templates, it's extremely hard. So Microsoft came up with a new initiative called Bicep this year. So Bicep is kind of a simplest form. so that people can utilize infrastructure as a code. And also Bicep is also providing, like, you can take an existing ARM templates. We have a lot of ARM templates deployment in many infrastructures. So you can take these ARM templates and convert to Bicep and start using it. But Bicep is in like early stages, so hopefully it will get matured over these years, and it will take some time. And why we need Terraform, so why we need Terraform is like, why can't I run like PowerShell commands and start populating, or I can use some AZ commands and start populating the infrastructure? Why we need Terraform? So when you start learning with Terraform, it's kind of a more simple product and easy to understand code. And I'm also kind of a non-developer background. I'm not a core developer. I started my career with infrastructure and all this. So even for me, Terraform is kind of a piece of cake for me to understand and start using it in a couple of months and mature the code. It's much easier for me. So I felt like it's extremely important for anyone, any consultant, to know this product, because if you're planning to work on any cloud platform like Google Cloud or AWS or Azure, Terraform will be your first preference nowadays, because any cloud you're planning to use, Terraform will support you. And for any consultant, so for any consultant, let's consider he wants to deploy the same type of infrastructure. Earlier days, if I want like 5 VMs or 5 Kubernetes clusters or 5 application gateways or any sort of deployment I want to make, let's consider I'm an external consultant. I know that this is how my product works, like one app gateway, one Azure Web App Service, one storage account, and any form of product will come into like coupling of Azure products or coupling of like AWS products. You can build like a simple code. It's for a consultant, so you can reuse the same code on all your projects for implementation. This is on a consultant point of view, that he needs Terraform. And on a learner point of view, let's consider in olden days, maybe if you want to deploy like 5 virtual machines, and if you want to test something and remove it, like I want like 4 2012 R2 VMs and 5 2019 VMs, and I want to populate this infrastructure to create some lab and come out of it and delete it. Now I can do it like in like $5 to $15. What I can do is I can populate all these virtual machines in using Terraform, and I want to test few things. I create the scenario, test it, and delete and destroy the infrastructure in like a few minutes. So this flexibility which Terraform gives is something amazing, and it's like anybody can understand, and it's not kind of a complicated product. It's definitely a good piece of technology, like piece of code, which I would feel like any developer or a consultant or any IT background guy has to know this, so that I feel this is the future. Because you work with the employer, so employer maybe work with AWS, or he might be using Google Cloud, or he might be on Azure. So like 95% of organizations going to use any form of cloud, definitely at one point. At least if you know one infrastructure as a code product, so that you can use that to interact with any cloud technology. So for example, also there is a misconception in terms of multi-cloud technologies. So what is the misconception is like, I use Terraform, so Terraform will support all the clouds. So people have a misconception that I write like 10 lines of code and I can reuse the same lines on all the cloud platforms. The answer is no, because like you're just using Terraform as an interactive medium. Like Terraform builds your backend ARM template. It just interacts with the backend templates of Azure, APIs of Azure, and populate this infrastructure for you. So if you want to interact with AWS, it comes with a different set of commands. So in the right side, it's a very basic command on creating a resource group. So if it's something on AWS or Google, these commandlets would change. So you have to rewrite as suitable for your cloud technology. So in this slide, what is Terraform? We covered as infrastructure as a code, and also ARM templates is kind of adjacent, much complicated to use, and Bicep is kind of a new infrastructure as a code initiative coming up with Microsoft, and it will be used only on Azure at this point. And why we need Terraform? Like Terraform is the future for infrastructure as a code at this point. So to interact with any cloud technology, Terraform is more stable, and they are releasing more amount of new versions every day. And Terraform with multi-cloud, so that you learn Terraform and you can interact with any cloud technology. The predominantly, like, you have to know how the cloud works, and if you have to be really familiar with on how the GUI works, so that you can use Terraform. Also, why we need Terraform is one more thing is why we need infrastructure as a code, in the sense, like, let's consider in a proper DevOps environment, you might see like 30 to 40 people working on an infrastructure. So let's consider if you're in a basic VMware environment, and if you have like 300 VMware administrators, the old concept is like each guy will have access to VMware, and you put a change management system as a document, and you get approved on a change management system. Then you go to and change on your VMware, but you don't really have a track on what is the exact change, even though you have like auditing systems, or you can have like logs collected into a centralized log system, and you analyze the changes, but still, like, you cannot protect the infrastructure before applying, and also you cannot get a real clear picture on what has been applied and how this can be reverted. So Terraform, as it's kind of always a set of code, and it can be pushed on a Git system. Git system is kind of a code repository, so any changes it tracks into the versioning system, so you can revert the infrastructure at any point of time. So this is also a booming thing, that that all the infrastructure has to be on a code point of view, so any changes can be tracked easily and it can be reverted. So it's like, it's not easy to implement at this point, but it can be implemented. We can implement and it will run, but you need really good amount of Terraform knowledge to manage these type of environments. But this is kind of what we see is kind of foreseeing the future in kind of any industry who wants to have all changes to be tracked and reverted, and to have a stable infrastructure, and all the, let's consider you built like 5 to 6 environments in a proper Hyper-V environment or a VMware environment. It's really hard for a human to create these environments in a proper versions, like the test environment, UAT environment, all these environments cannot be identical at this point, because somehow you will miss somewhere some settings. And in order to track over a period of time in any environment, if you see that over a period of time that all these environments go in a different form, the test environment will be like becoming more messy, UAT becoming like more change, the system will be more different. So you lose track over a period of time. At least when you have Terraform, I'm not saying like if you have Terraform, it will not become messy, but at least you have control, or at least you have proper history on what happened to this environment on like over the years, right? Okay, those things. And so I hope this is covered, and let's check the next topics. So why companies needs Terraform? As I said earlier, like if you have more developers, or if you have more infrastructure guys has to work on the same infrastructure. So earlier in an on-premises scenario, what happens is you have a set of network devices. So it will be managed by network team, and you have a set of infrastructure components like VMware, and you have like virtual machines, and you have load balancers. So this can be managed by different set of teams in on-premises world. But when it comes to the cloud, all are interlinked, and people will call it as DevOps, and all the people has to work together in the same set of products, right? So let's consider the guy is going to deploy app gateway cannot be from networking team, and like it's very hard. Like the storage guy will have access only to storage accounts. So this concept is almost kind of gone nowadays, because it has to be kind of a DevOps team, and people have to work together in order to formulate an architecture and implement. So in order to like have a proper governance on top of this infrastructure, only an infrastructure as a code can achieve this form of governance, because so any sort of changes in the environment, it can be tracked, and all the teams can work together. All the teams can test things and implement on the production easily. So this is the real advantage of Terraform. So that is the one thing. And also in a consultant point of view, let's consider we are seeing like many kind of scripts, like in a external consultant point of view. Like if you're formulating any kind of a project, even in the design phase, let's consider you need to have like three Kubernetes clusters, 4 app gateways, or if you want to have like 5 to 6 storage accounts which should not be internet facing. So all these can be put into the Terraform code in the design phase with the consultant, so that when you go to the implementation phase, you just push the code and the infrastructure gets populated. So it's extremely useful on a consultant point of view, that if you want to implement anything on a customer facing environment, you can implement the same set of code into your lab or something, and you just change these values and you go to the customer environment and you implement it. So that's also, it's a good thing on Terraform. That let's consider in a different scenario, irrespective of what cloud the customer is using, we don't have to worry, but you just need to have Terraform code for each cloud. For Google and Azure, if you have these set of codes, so most preferred cloud let's consider it's Azure. So if you have this set of code, even let's consider if you want to do kind of a VNet peering or anything to MongoDB databases, or anything can be formulated in a predefined code, so that it can be modified as per the customer's environment and you can implement it. So it's also another advantage we are seeing. So in order to work with Terraform, we will do some few like examples, so that we don't end with only slides. So I really want to explain on how it works. So let's see a little bit of Terraform and installing Terraform, and we will come to this slides again. Okay. So yeah. So other thing what we are seeing is so what we are doing is we are opening is the Visual Studio Code. So Visual Studio Code, for if anybody who is not using Visual Studio Code, it's kind of a normal like PowerShell ISC, I would say, because I'm kind of a PowerShell background guy, so I'm comparing with PowerShell ISC. So this is the new product from Microsoft. So people start using Visual Studio Code. So you can install it. It's a free product and it doesn't require any license. So let's do something and. So. Okay. So let's go into AZ logins. So. Yeah. So let's consider first what is AZ login. So it's kind of another CLI provided by Microsoft. So if you want to do AZ login, you have to install the AZ CLI. In order to, you just Google like how to install AZ login, you will get an AZ CLI. You have to install that first. Then you have to do AZ login. So once you do AZ login, what happens is you get a Microsoft PowerShell MFA prompt. You enter into you put your Azure portal logins. So once you enter that, what happens here is you can list all your Azure subscriptions. So in a normal scenario, what you will see is you will see like only one subscription. But if you read about cloud adoption frameworks and we call it as CAF. It's kind of a fancy word, like, do you have CAF in your environment? Do you have CAF implemented in your environment? It's becoming kind of a fancy word, that do you have proper subscription planning? Do you have proper management group planning? Do you have proper hub and spoke architecture in your environment? So maybe in one word, you can ask this as, do you have cloud adoption framework properly architected in environment? So what Microsoft is saying is, if you're implementing any new architecture in your environment, Microsoft is providing the CAF design, like cloud adoption framework design and best design principles. So in best design principles, what they are saying is you have to have multiple subscriptions for your business units. You have to have dedicated subscriptions for on your hub unit. So I'm not going to go in detail on CAF, but that's why you have multiple subscriptions. So that's a short explanation of why you see multiple subscriptions. So when you see in AZ login, when you have multiple subscriptions, you can see you're working on this subscription, business unit 1, for example. Let's consider if you want to switch your subscription and work on a different subscription. So let's do that. Let's consider I want to switch to a different subscription, and I say AZ account set --- subscription. And let's consider I want to work on business unit 2, for example. Then I just use this and I switch my subscription. So if I do like this again, AZ account list -o table -all. If I do this, I switch my subscription. If you see here, I was switched my subscription. So if I'm going to run any sort of Terraform commands, now the deployment will be happening on this subscription. So I'm talking in very basic terms because I think this will be a starting point, because after, when you go into a proper DevOps model, you can interact with multiple subscription. You can deploy with multiple subscriptions in the same time. I'm not explaining this today, but what I'm saying is, as a starting point, if you have a lab environment, or even if you have a test subscriptions, ideally you have to list your subscriptions and you have to move yourself to your test subscription and make sure you are in the test subscription, so that you can deploy this Terraform, or if you're testing any code, so that you're affecting only on that subscription, so that you're not moving away to any other subscription. Okay. And if you want to log out from your AZ login, and if you want to move out, so if you want to move out, what you will do is, if you do AZ logout -- username, and you will put your email address, whatever the email address you are using, so you can log out from AZ. I'm not going to log out now, so I just come out. Okay. So as I said earlier, now you have the subscriptions. Now you have, now I know that which subscription I am working on. So I know that Terraform. Now let's move to Terraform. Okay, so you just download the Terraform exe to your, it will be a small exe file. Just Google like Terraform download. You will get Windows form. Every operating system has its own methods, but let's cover Windows today. So you just download this exe file and put into C Terraform folder. Okay. Then you go to your system properties. So as Hussam said, like I'm using like sysdm.cpl, so that we can choose the environment variables. So if you go here and path, if you just go here, I'm just saying my Terraform is in C/Terraform. So I did that. So if you go here, C Terraform, my exe here is here. And also, if your Terraform versions need an upgrade, it's so simple. You just replace this exe, or you can do an auto upgrade. It's so simple. It's just simple exe file. That's the exe is responsible to interact with the system. So also, once you do this, it may require a restart for a Windows operating system. Then you do a Terraform version, for example. It means like I'm running Terraform v1.02. This is released recently. It has a lot of good features. And also now what we have covered is, like, we know the subscription, we have listed the subscriptions, and we know what subscription we are working on, and we have the Terraform is ready. Okay, so that is done. So let's go back to the slides. Okay, So now we know what is AZ login, AZ modules login, and we know how to list the subscriptions, and we know how to switch subscriptions with the subscription IDs, and how to install Terraform, which is also we covered, and we also know how to add this environment variable on the Windows operating system. Then you restart, or then you just run the Terraform version on your Visual Studio terminal. Then it just makes sure the Terraform is installed and ready. Okay. So coming back to Visual Studio Code, what it's kind of it has its own extensions. So if you go to your extensions and you can search for Terraform extension, it is already installed. Maybe you have to Terraform and it will ask you to install. So what this extension do is, when you're writing any basic Terraform commands, if it's not in the proper syntax, or if there is any error, it will just highlight it for you so that you can fix it easily. So which is also a good thing for any starter. This Terraform extensions is really helpful. So coming back to Terraform, init, plan, apply, destroy. So Terraform works on this 4 stages. So when you initialize, you initialize the Terraform, and it creates kind of a local state, So you would have seen a bit earlier that I was trying to delete some state files. So let's dig deep on that so that we understand init, plan, apply, and destroy. So what init does is, if you're planning to initialize, it creates a local state file. And if you're planning to plan, it's kind of what if in your PowerShell. For example, it will not apply, but it will tell you what will happen if you're going to apply. And you apply, it means you're applying the command. And if you destroy, it's like whatever is in your local state file. So let me explain more on the local state file. So when you initialize, for example, let me initialize. OK. So let's consider I do Terraform init. So I have like in TF files. I'm not explaining now what is this TF file. Let's consider I have some TF files. I have some TFR files. Then I just do init. So what this init is doing is, it will just a second. Yeah, so I'm not in the right folders, so I have to go to Azure resource group. So I'm just browsing into this resource group. Then I do Terraform init. Okay. So let's go to this file so you can understand what it's really doing. So I'm into this folder. So if you see C scripts resource groups, I'm in the same folder. So let me do Terraform init. Okay. So what it's doing is it's downloading all the required binaries for Azure, and it's installing. It's making sure the Terraform exe is available, and it's initializing to have an LT backend. It's kind of, we cannot say it's a database. In Terraform, we call it a state file. So whatever from here, now whatever you're going to create through this Terraform system, through this Terraform code, so it's going to store that I have created like 5 resource group. I have created 5 virtual machines. I have created like XX things on Azure. I have created XX things on AWS. Whatever I'm going to create, it's going to store that in the state file. Okay. In a production environment, what it will do is they will not be doing this in a local state file. So let me go into resource group. If you see after initializing, you will see some extra files. So what it has created a state file. OK, you will see some state files getting created. So initialization is done. So let's consider I do. So I said it's kind of a 4-stage things, right? So I do Terraform plan. So it's kind of what if being done on a Terraform or like PowerShell. OK. So let me run Terraform plan. So in this set of code, what I'm doing is I'm just trying to populate one resource group. OK, so So before going there, I will say Terraform plan. I said kind of what if in PowerShell it's not going to apply, but it's going to say that what will be done in this environment. So what will be done is one resource group, one to add. So what I'm doing is I'm creating one resource group. So okay, so let me cover init plan, and then I will explain what is TF files and TFR files. Okay, so now I hope you guys understand what is initializing. It's creating the local state file. So when I do plan, it's going to tell that what is going to happen with this set of code. So it's not going to change anything. It's not going to destroy anything, but it's going to add one resource group for me. So if I do apply, so what it will do is it will create this resource group for me. Okay. Let's apply that. So let it get applied. Okay. Let's come back to that. I thought it will create quickly. Yeah. So yes. So what it's saying is it's asking to confirm. So I say one to add. Can you confirm? So I say yes. Okay. It's getting applied. It's getting created. So if you go to so let me go to Azure portal. Okay. Okay, so you go to resource groups. Yeah, if you see this resource group created in business unit 2 as we specified on the AZ commandlets, and we just ran this code. So let's consider I want to destroy this resource group. So I'm just giving you an example. So this is just one resource group, but in a typical lab scenario or a consulting scenario or testing or creating some kind of a huge lab to test some scenarios, it will be like 5 virtual machines or 5 app gateways or 5 Kubernetes clusters. You can do almost do anything. If you want to populate and destroy it, then test it again. You know, that is one thing. Okay, so let's destroy this environment. For example, so it's getting destroyed. So what it's going to destroy is, let's see, yeah, it will destroy the resource group. So it's saying when I say destroy, I'm going to destroy one, and I'm going to destroy this resource group. I'm going to destroy the resource group in this subscription. Okay, so say yes. Okay. So that resource group will be gone now. So, okay, so now I hope you guys are clear that init creates a local state file, or it's going to store whatever you're going to do it. When you do plan, it's going to say what is going to happen in the environment. Are you okay to do it? Then you are sure that your planning is good. Then you apply. It means you're applying the changes. Then you test whatever you want, and then if you don't want the environment, you want to save money in a consulting point of view, you just destroy the environment. Okay. In a DevOps environment, this local state file will be on a storage account. It will not be stored on your local system, so that because this is your brain of your environment, right? So you will not be storing in your local machine if you're using with Azure DevOps. So as a starter, you will not go into Azure DevOps, but you will create local state files. You will play with local state files. You will destroy. You will create, destroy. You can do almost do anything. But the advanced stages, you will be storing this local state files into the storage account. So you can apply this versioning. You can do backups. And also, let's consider some people are implementing Terraform on a new environment. What Terraform supports is Terraform supports import modules, which I will be saying in the next slide. So when you import, what you can do is you can take an existing infrastructure and you can implement like import into the Terraform states because it was not created using Terraform. So it means like if you want to implement Terraform in a new environment, it's also Terraform supports such things. Okay, so now you know installing Terraform, now you know init, plan, apply, and destroy. And local state is for your local machine. Whenever you initialize on local system, all your brain of your Terraform stores on the local disks. When you on an enterprise environment, you put all these state files on a storage account, not on your local disk. So use when you store on your local disk, it's called as local state. When you store it on your storage account, and when you use through DevOps, you can call it as a remote state, so that you are making sure your remote state is always available, it's backing up, it has proper versioning. And also okay, so let's discuss a few things on remote state corruption and few disadvantages of Terraform. So all this time I was telling about the positive side of Terraform, but we have to be clear on what is the disadvantage of Terraform. Okay, so that we are aware on what this really does, and what's the complications, or what is the disadvantages of Terraform. Okay. So in ARM templates, and I was telling Microsoft is providing ARM templates in the initial slides, ARM templates, Bicep. So the advantages of ARM templates and Bicep is like it doesn't create any sort of state files. So it's kind of you run those files, and this files doesn't store anything. It just applies on the environment, and you populate the environment. It does not store anything. But what Terraform does is it's storing your state file. So if something bad happens to your state file, but in some scenarios, Terraform state files even gets corrupted. You have to revisit the state files, and you have to maybe restore from backup. You have that one complication, but it doesn't happen usually in the new versions. But it's something you have to know, the advantage and disadvantage, that ARM templates and Bicep doesn't have any sort of state files. So if you change something, you really don't have a backend on ARM templates or Bicep. But in Terraform, you always have a backend, and you have to take care of something which is the state files. Okay. And also the other disadvantage of Terraform is, let's consider Microsoft is releasing, even though Microsoft and Terraform have a very healthy partnership now, but still when Microsoft is creating some kind of new technology, let's consider Azure Firewall Premium is releasing tomorrow, or it came online. You cannot test that with Terraform, because Terraform will take Terraform, HashiCorp by Terraform, this company will take its own time to build the modules for Azure Firewall Premium Preview, or if the product. So we have to wait on that. So that is one of the disadvantage on Azure, on any sort of preview products or any sort of newly released products. You may not see Terraform modules, but like most common modules, like all the products, Terraform has modules on all cloud. Most of the things Terraform supports it, but the advantage is, like, let's consider you have taken the decision in your environment that I will never use GUI. My whole DevOps team will use Terraform through DevOps and implement this in my infrastructure. We can take this decision at this point, but it will come with a price on. There are certain things you cannot implement. You have to wait on Terraform. So that is the disadvantage Microsoft is seeing. Maybe when it comes to Bicep, ARM templates are ready from day one, and anytime you can take Bicep and convert this ARM template and use it on day one on any product. But when you are implementing Terraform, you gain this, you get this disadvantage that newly released products, you cannot use it, but you gain the advantage of multi-cloud, that you can interact with any cloud provider at any point of time, and you are more flexible. So I hope this is clear, that you take the multi-cloud advantage, and you have a state file to manage, but ARM template bicep don't have state file, but they don't have a real multi-cloud support in order to provision things. So this is the gray area. You have to decide on what you really need. You are a company like state of the art, then that you implement on day one that any product release on Microsoft. So it totally depends on how your strategy works and how is your impact on if you don't implement something which is not, you got the point, right? Yeah, that's what I'm trying to say. Okay. So creating resource groups using Terraform, which I just showed you. So recreating local state. So let's consider if you want to recreate the local state. Okay, so what happens here is, so let me show you something. Okay, so Terraform state list will show you something kind of a local state. If you have now I destroyed everything, but if you have something created, what it will show you the state, and you can delete the state. Or if you're simply playing with the Terraform and it's a dirty way of deleting the state files, as you go here and you just take off all these files, it means your state is gone, right? So this is how it's like deleting the state file, and you can create something new if you want to do that. If you're like midway and if you want to try something out, if you want to clear the state file and then you start with new, you can do that. Okay, that is one thing. And you know how to recreate the local state now. Okay. And yeah, so let's explain Terraform TF files and TFR files and modules. Okay. So coming back to the code which I was running, it was the most simplest code you can ever find. And I'm not explaining any sort of advanced code, but I will show you something which I am using just for fun. Okay. So what I am doing is here is, so we can first is, if you have TF files in the same folder, you can put any TF .tf files. Terraform will recognize as Terraform files and it will see it as a single form of code, but for better understanding, I'm just putting in different files. So even if I'm going to copy paste this providers and main TF in a single file, it's going to work. Okay, but for better understanding, I'm splitting this so that you have more understanding. Okay, so the first is main.tf file. So what I'm here doing is I'm using a resource and just I'm putting a name for that this function. Okay, then I'm using main. This is just a standard template. If you just I'm just showing you for resource group, but as soon as you Google and you can get any templates for any product on Azure at this point. So let's consider I'm using the same resource, the name and the example, just you can put main and the name of the resource group. I'm not specifying any location in this. Okay, so I'm just using resource and this I'm putting main. Okay, so here in this line, what I'm doing is I'm just using a variable. So variable in the sense I can put the resource group name here itself and populate this and make it work. But why I'm putting a variable is, let's consider you have like 5 to 6 virtual machines, and if you have like 5 to 6 app gateways, it's always recommended that you use variable. There are so many methods, I will explain you shortly, but what happens here is I'm using a variable here. Okay, then I go to the variables file and I will say what is my AC resource group value is. So what I'm saying is var dot, this is my variable. Okay, then in this file I'm saying my variable value is Azure 365 Pro, for example. Okay, so what I'm saying is if you're going to have 5 to 6 or more folders and more files, it's always good to have a variable file and you declare everything on the variable file. So when you want to change something on your environment, you don't have to dig all your folders and files on a more advanced scenario, so that you always prefer to, I will not say preferred because it has various scenarios. So it's good for this scenario what I'm talking, that I'm declaring the variable in the variable file, and I'm populating this, and so when I'm going to apply on this folders, so what it's going to apply is it will go into this folder, it takes the variable file and say my variable value is this, and it's going to use this TF file, okay, and I'm going to create a resource group. What is my resource group location is East US. So even if you want to populate this East US in the variable file, you can move that, but I want to show you that you can put this in this function and you can declare it here, or you can put a variable and you can bring the variables into a different file, or you have one more method that you don't have to declare anywhere. You can use something called a TF file, so that let's consider you build a set of code, okay, like 5 to 6 products you have already built. So each environment, maybe you will say VM name is XXX, and you will put like 5 virtual machines, and you will just put the names and Kubernetes cluster names. You can maintain a TFR file to populate the environment. So as I said, the first thing is also this provider. So in this example, I'm using Azure Rm Provider. So even in this provider, you have options. So let's consider you have built a production ready code in DevOps for 0.15 in Terraform, and you have tested this code. So in that case, you will specify in the provider saying that run this only on this version of Terraform, if not fail, So in this, I'm saying whatever, I'm not specifying anything. So it supports the latest versions. As it's a test code, I'm not specifying anything. Also, you can interact with an Azure AD service principals, and it supports that also. But let's discuss on the basic topics on providers. I'm using Azure Rm Provider. I'm not specifying anything, so it's using the latest Azure Rm Terraform versions. I'm not restricting anything. In the main TF, I'm just putting a simple variable var dot this one, and I'm specifying this. And then in the variables file, I'm specifying the variable. So even you can remove the whole variable file and you just run with only these 2 files, it's going to succeed. So, but I want to explain you all the options that you can keep these 2 files and bring these variables to a variable file, or remove this and take this to a TFR file, So 3 ways, actually it's 4 ways, okay. So first is the variables. You specify the variables here. You specify directly the value here, or you bring the value out to a variable file to have a neat management. One more step, you can remove the variables here and take it to a TFR file, so that you can maintain kind of a reusable code. So if you're using TFR file and if you have like multiple folders, you use only the file TFR file, so you can run like this. I'll show you this. Instead of running TFR file, so you will run like this. When you do plan, you will specify the TFR file, so it will not reuse you will not use your variables file. It will use your TFR file and apply the code. So let's consider you're a consultant, and if you have a proper healthy code, then you will ideally use a TFR file, so that let's consider I will put a TFR file. I will have like 5 to 6 machines names. Then I change every environment. I change things, So that's how it's a good feature, So Azure DevOps Terraform modules is like it's kind of you build a reusable code in set of folders, and it's an advanced topic I'm not explaining on this session. And Azure DevOps with Terraform, which I already explained, that you create a remote state, you have a storage account, and you have store the state file in the remote state, and you run the DevOps. So I want to explain that quickly. So what you create in a DevOps methodology, what you will do is in pipelines, maybe you will use Terraform, and what you will do is you will run this task. So what you will do is you will do init, and you will do plan. but you will not apply. Maybe you will send this for an approval, and after your approver approves that this is the set of changes happening in my environment, then you apply the code. So the next set of pipeline will run like Terraform Init and apply the code. So this is the type of flexibility, and I feel this is a future. Maybe it would be Terraform, or it could be a much more matured infrastructure as a code. But at this point, Terraform we see is one of the best product in the market to achieve this, like to a state of 98 to 99%. So that is it from my end, guys. So if you have any questions, please do ask it in the chat so that we can go through that. Okay.
Thank you, Sathesh.
Yeah.
And yeah, this is a reminder for everyone to send us questions about the topic of today's session, and we will spend the next few minutes covering that. Make sure that you also check and follow the module that I shared with you in the meeting chat. This is a module that Sathesh has recommended for you to continue the journey after the session and not like stop learning. In fact, there are lots of learning modules on Microsoft Learn that can be beneficial for you. And also you can use Sathesh's blog, Azure 365pro.com as a reference, and have a look at all the content that Sathesh is actively producing and sharing on his technical blog.
Hope the session was informative, guys. If you have any doubts or any clarification or any sort of thought process, just put it on the chat.
So here's a question. Could multiple users have access to one state file?
The short answer is no. So that's why when DevOps runs, it locks the state file and writes things, then it releases the state file. So even when DevOps, even if you use the same state file and if you run multiple DevOps things on that, so it's each process will lock the state file and it will do the changes, and then it releases the state file. So it's always one, but yeah, everyone can have access, but when you run it, it's going to store it only one guy can apply changes on it at one point of time. So what are the alternatives in Azure tool in Terraform? So yeah, so in Azure, as I said earlier, like you have ARM templates. So ARM templates is really flexible, but it's too complicated to handle because it's using the native JSON technology. So it's kind of too complicated to troubleshoot. When you miss a double quotes or when you miss a comma, it's extremely complicated that where you missed it and how to bug fix it. It's very hard. So that's why Microsoft came up with Bicep. Bicep is really getting like mature. Microsoft investing on Bicep like very hard, and it's becoming like matured like so fast. So that is there. So Bicep is there. Bicep is the alternative, but Terraform is it's more simple, man. You should try it. You should try it in any non-developer background or developer background. It's for all. So this is what we are seeing. Yeah. Thank you for your question, Maxim and Abdul. Yeah.
I took over the screen sharing to remind everyone that these are the channels and the YouTube channel as well, where they can find all the content that we're recording here at the Reactors, and also connect with us on social. And Meetup is our main platform for all the community members, which they can take part, register for events, and find all the upcoming happenings. The Reactor email is a newsletter. That's the fourth link there in the slide. This is a monthly newsletter where we share all the interesting happenings in the local or regional, I would say, Reactor. So you'll get a version for Europe, a version for Middle East and Africa, and a version for different parts of the world. So you can select on that page which ones you would like to be notified about their events and happenings, and that will get you one monthly reminder in your email of all the interesting live sessions that are happening. So make sure that you are subscribed also and not miss any of our upcoming sessions. Speaking of the MIA series, I'm waiting for more questions to come, and I will draw some reminders maybe to the MIA series, where we're going to continue folding in more sessions into the series. And the details are confirming. I'm having conversations with different speakers and Azure community leaders across the region to have them speak as part of the MIA series, which today's session is part of. So expect more happening, expect to see more on the series page and on the YouTube channel. Well, I think, all right, here is a question. It was saying, are there any tools for converting Azure blueprints into Terraform scripts and vice versa?
Up to my knowledge, no. The answer is no, but definitely I have to double check this, Iqbal. But so as far my experience, I never seen any scripts so far. What we have seen is ARM templates to Bicep is what we are seeing, but I haven't seen blueprints to Terraform scripts yet. Yeah.
All right, I think that's all right. Thank you for the clarification, Iqbal Singh. And yeah, I would like to thank you, Sathesh, for joining us today on behalf of all the members and the community in the Reactor. It's always great to have you here with us and to learn from your experience. It's also good not for professionals in this domain to attend such sessions, but also to people who are trying to explore new areas and new domains, and what are the trends and what are the latest technologies, updates that are happening. And this is one of the interesting things that we're trying to do here at the Reactors and also in the MIA series, where we're hosting different leaders and technology professionals to speak about all what is happening in their fields. So this is a good way for anyone. So feel free to share it with anyone who's trying to figure out interesting domains and interesting ways to explore new technologies and new tools and so on. So the series is also partially aimed at enabling this to happen.
Yeah, thank you guys. Thank you for spending your valuable time with us. We definitely respect that, and thank you for the usual support from the community. Yeah, so we have one more question before finishing. Is there any, can you share more light with regards to the module? Yeah, so when we say modules, what happens here is, so let me. So when I say modules, it's like you will have a, let's consider Terraform init plan apply. I'm doing that, but let's consider I want to build an app gateway module, and so that let's consider app gateway releases some set of features. You don't play with the whole code. You know, you play with only the modules. Maybe in the future you might have a app gateway Terraform expert or app gateway Microsoft expert. You know, so that he works only on the app gateway module. So any new feature comes to the environment, he works on that module without affecting the whole code, and the same set of module can be used on multiple repositories, you know, so that's the advantage. And so modules, like that's modules with the pure concept of reusable code, so when you use modules, it's a huge topic because you have to take output from the modules and you have to bring input to the input tier first. Well, maybe it's kind of an advanced session which I would like to cover later, but yeah, this is the simplest explanation I could give. Is there any link between YAML script and Terraform in DevOps? So what we have seen is YAML files is, it's used only on the Kubernetes deployment. Azure Kubernetes service deployment, we are seeing a lot of YAML files. Then you use Terraform to push this. So, but there is no direct link. But in DevOps, to interact with Kubernetes, you will use YAML files. But if you want to populate the infrastructure, you use Terraform. So what about Ansible, Puppet in Azure? So Puppet is kind of the old king. So I cannot challenge. I cannot say Puppet is bad or Ansible is bad. Definitely they are really healthy products. But what we are seeing is even Microsoft is recommending Terraform in some places in order to populate Azure infrastructure. And we have what I personally see is a very healthy relationship. And whenever Microsoft product releases, Terraform comes up more faster than Ansible or Puppet. This is what we are seeing. Maybe Ansible and Puppet can achieve this. Achieve the same thing what Terraform can achieve, but Terraform is much more simpler. I worked with Puppet in the past, but what we see is Terraform. Even people coming from the non-developer environment can understand Terraform and start using in like 1-2 weeks is what we are seeing. Puppet is not the same scenario. If people are coming from a Linux background, Puppet is more easy to understand, is in my experience. Yeah. But definitely I cannot say Puppet or Ansible is bad, that's what I'm saying, but definitely it's Terraform is more simpler, is what I'm seeing, Abdul. And the other question is, if all DevOps team are using ARM templates with pipelines, has no issue with validation JSON and debug deployments, will we have any profit with the redesign approach of Terraform? So what we are seeing, Maxim, is like, let's consider if you're using ARM templates and if you're happy with ARM templates, Terraform does not bring any value to you, to be frank. But what happens here is, if you're a company and if you're planning for a good multi-cloud strategy, and if you want to reuse the same set of code on multiple clouds, practically it's not a simple lines, as I said, it's too complicated. The lines what I'm talking, that you build some Terraform set of code and start interacting with multi-cloud, it's kind of a most complex topic. But the short answer is it will not bring any value. But if you're already using ARM templates and if you don't see any need of multi-cloud provider, I would definitely ask you to look for Bicep to simplify your ARM templates. But Terraform will not give you any advantage in this scenario. Yeah, that's the answer, Maxim.
All right, I think that was the last question that we had from the community members. Thank you again, everyone, for attending today's live session. The session is recorded and it will be available on Microsoft Reactor YouTube channel. So check that out later on in the next 24, 48 hours, let's say, to recap, review it, and also share it with your friends and colleagues that may have not been able to attend it on the live. And as always, thank you, Sathesh, for joining us. Again, it's always a pleasure having you with us here, speaking to the community of the Reactor about all the latest technology updates and tools and how they can improve their workflows and understand all these trending concepts with the infrastructure as a code and everything around the Terraform. So thank you, and looking forward to having you later in the near future, hopefully.
Thank you, guys.
All right, goodbye, everyone.
Thank you, guys.